Hello everyone. Today I will going to the discuss another lecture, which is compressibility of soil. Uh, is given BM just chapter 11. So the topics will be covered on normal consolidation, over consolidation, on settlement, and time rate of the consolidation. So before I'm starting, let's see the some. Some of the formulas. Here is some formula which is we have shown here normal consolidation and over consolidation between delta sigma c and sigma naught and sigma c. Settlement, how we calculate the settlement when sigma naught is greater than pre-consolidation, and also sigma naught plus delta sigma, where is the delta sigma is also greater than the pre-consolidation, then we will use the NC. When we will NC normal consolidation, then we will use the formula of CC. CC we will found here the sum of the formula of CC is CC. Sorry, is not here. Here is the sum of the formula of CC. 0.009 liquid limit minus 10 Cc equal to 5 into Cs, Cc equal to delta C into log E minus E by C. So and then use the settlement formula Cc into H divided 1 by E naught plus log mass sigma naught plus delta sigma into sigma naught. And another, when we will see the sigma naught less than pre-consolidation, and also also sigma naught plus delta sigma also is less than pre-consolidation, then we will use the OC, over consolidation. Or then we will use CS. Here is the CS. Settlement CS equal to H divided by 1 plus sigma naught plus log and log sigma naught plus delta sigma divided by 1. And then when we will see the one condition on sigma naught is less than delta pre-consolidation stress. On the other hand, we have seen when they use the delta sigma, then that is the greater than pre-consolidation, then it is both CS and over consolidation and normal consolidation. Then you will use two part which are CS into H divided by C naught log delta sigma into C naught, and CS H divided by C naught and delta sigma pre-consolidation divided by C naught. And for quick consolidation, we will use the some settlement is as equal to MB delta sigma. These are the formula. I'm not saying and the coefficient of consolidation CB equal to 0.197 at H square TB, and permeability also. Here is the CS equal to CC divided by CS equal to 0.046 into ligate limit minus plus limit. Over consolidation, which is the here. When we will say normal consolidation, then over consolidation ratio is 1. When the over consolidation ratio is greater than 1, then we will see the H problem. When the point there is a H problem for the funding delta sigma, and we have used find the delta sigma in 3 way. One is 2:1 ratio, which is from 2:1 slope, P divided by P by Z plus L by Z, and another is Q by I, and another is delta 3 by that whole delta sigma. And time factor here is CB into T, and time factor C when the when U equal to 0 to 6%, and TB equal to when U is greater than 60%, and CB equal to E, and this, and the length of the drain is at dr H by 2 1 into H 1 is when the true drainage were in place. And okay, let's see here. Let's start from the beginning before so here the total settlement. We can see here the total settlement is primary consolidation settlement, secondary consolidation settlement, and elastic settlement. That will be total settlement. Okay, secondary. So we can see the secondary settlement. It is appear after the 15 years of the building, and consolidation delta sigma. So here is a consolidation foundation of the soil. We're not seeing here. This is the clay and this is the sand. This is the sand and drainage system, and pore rotor is trying to seepage here. Pore rotor is trying to find out here. Delta sigma is a extra load or pressure. Delta is a extra pore rotor pressure. Here we can see when the T equal to 0, then stress increase. Here is the stress increase. Pore rotor pressure increase. Here pore rotor pressure increase, and effective stress is 0 because there is T equal to 0. When 0 greater than T equal to infinity, then we can say delta sigma is here, and delta sigma is here because the water is spreading, and the delta sigma is here. When T equal to infinity, then delta sigma is here, delta sigma is more, and delta sigma is here. And the pore rotor pressure will be 0, and the delta E log effective stress will be delta stress equal to effective stress. So we can see another graph which is log scale, which is stage 1 initial compression, primary consolidation, and the secondary consolidation. The initial stage, the initial compression, which is caused mostly by freeloading, and the second stage, which is primary consolidation, during which excess pore rotor pressure gradually transfer into the effective stress. And stage 3, the secondary condition, secondary consolidation, which is offer completely dissipated of the stress. Okay, let's see the Boyd ratio pressure curve, which is called, we know, the E log P curve. We can see here the E log P curve, the compression CC. This is the most important formula, as we know, but we are seeing how the formula has derived. You can see here the y-axis is Boyd ratio E, which is E, the maximum E, and E1, E2, and found the stress stress 1, stress 3, and free stress. So we will find E2 is here pre-consolidation. The pre-consolidation is left side is over-consolidation and right side is normal consolidation. So CC is E2 minus E1, E2 minus E1. That means this portion only, and sigma 2 minus sigma 1. There is a sigma 2 minus sigma 1. There that means this portion. So we call this is the compressibility index CC. So here we can see here normally consolidation. The definition we have seen here. The normally consolidation whose present effective overburden pressure sigma is maximum pressure at that soil was subject to in the past. Okay, the over-consolidation whose the present effective overburden pressure is less than the which is soil extracted in past year. Here is the over-consolidation. You can see here the pre-consolidation, the which is less than the which soil is extracted in previous experience in previous. Pre-consolidation, the maximum effective past presence in the call the pre-consolidation pressure. So we can see a pre-consolidation pressure in the left side is must be over-consolidation, and right side is normal consolidation. Remember it, when the normal consolidation, then we will use CC, and when the we will use the over-consolidation pressure, then we will use CS. Okay, let's start the over-consolidation. Here is the over-consolidation OC. This over-consolidation A and C, normal consolidation. We know the over-consolidation ratio is sigma B by sigma P, and pre-consolidation here. We know the normal consolidation is is OCR ratio. Over-consolidation ratio is 1. On the other hand, you can see over-consolidation ratio OCR is greater than 1 when the over-consolidation. So here is the Boyd ratio. We can see here the load is decreasing, and then load is increasing, and then load is decreasing. When the load is trying to decreasing, that is the over-consolidation. When the load is increasing is over-consolidation, decreasing in normal consolidation, and effective overburden pressure is here. I will draw the pre-consolidation. Here is the pre-consolidation curve. We can see here. So let's try to draw. At first we are select the point A. There is a point is we have select A. Whose the curvature is maximum. This is our curvature line. This is our red line I have drawing here. The curvature line, and draw at the horizontal AB. This is the AB horizontal line AB we have drawn here, and the tangent is AC. We have drawn another line is tangent AC from this curve. And the midpoint, how we'll get this midpoint? We are taking the compass here and another compass is here. This is the midpoint, and trying to the here. This called is midpoint D. So AD, is here is drawn. Another line, draw the tangent HZ. Here is the H and here is the tangent. Then we will draw the line HZ is here and intercept point F. This is our vital point is F, which is intersect. Now we'll draw the drag line is here, at the bottom. So draw the vertical F and sigma C line, and so find the pre-consolidation C. So this is our pre-consolidation curve. So in this way we can draw the pre-consolidation curve. So before we going to we are seeing the some formula here. The over-consolidation is here. The normal consolidation is here, and pre-consolidation is the maximum effective stress we know. The settlement we are here. The settlement when sigma is greater than sigma naught or sigma p, then we will use a normal consolidation, and settlement formula will be this. And when sigma is less than C, and this formula will be used, and settlement formula this will be. And when we will condition satisfy the both condition, when sigma naught is less than pre-consolidation, and on the other hand sigma naught plus delta sigma is greater than sigma e, then we will use this portion 1 and portion 2. And the compression index is there is three type of formula we have used. CC equal to 0.009 liquid limits and 10 when the liquid limits is given. On the other hand, when CC is given, then we will use the CC 5 into CS. And CC we have known delta E divided by log sigma naught into delta sigma is here. So effective stress we know how we'll get the effective stress gamma prime into Z. Gamma prime is nothing but saturated minus minus void of water, and the extra or applied load we can say delta stress. We have shown here the another curve. The pre-consolidation is delta C, and H is the layer of the soil, and showeling index we have already here shown here. We can calculate quickly his settlement as equal to MB delta sigma H. So as equal to delta sigma H equal to 1 plus E, so when the normal consolidation, and MB equal to this formula. And the CB we can permeability we can calculate here also. So time factor we can also calculate CB equal to TB. This formula we can use. This formula we can use, and we will compare with this formula. So and TB is here, and drainage product is here. So we have to must be memorized memorize this formula, or we have explain this formula. We have to must be memorize this formula. Otherwise we will not will not go the further condition. So here we can see here when two-way drainage, this is the soil, and when the layer portion is clay and upper portion is sand, then the water is seepaging through way, then we can say 2 dr. So 2 dr into H, here is a H, and dr equal to H divided by 2. So this is our main basic how we'll get H by 2, because it is drainage in 2 way. On the other hand, we can see here, because this soil layer is clay is bottom, and another is sand. On the other hand, we can see the second condition, if there is a stone and another is clay. So drain seepage is one way drainage condition. We can see one is drainage condition, and another is stone and clay. So we can say here the one way it is. So let's start the example. The soil profile, here is the soil profile is given, shown the figure is uniform distributed delta sigma is applied in ground force. What is the settlement in clay layer caused by the primary consolidation? If clay layer is normally consolidated, so NC, so CC will be used, and the pre-consolidation is 200 kilonewton per meter square, and sigma C is 150 is given. So we have shown here, this is the soil profile is given, and applied load this 100 kilonewton, and layer 1 is sand is 2 millimeter, and another one is 4 millimeter, another one is clay, and another one sand. So dry is 14, and saturated and 18, and saturated 19, and void ratio is 0.8, and liquid limits also is given 14. So let's start. So first of all, we are trying to effectively stress. We are trying to find out the effective stress at the mid level of the clay, which has sigma naught. So this is our first layer. So we know the gamma into Z. So gamma we know 14, and Z is 2. So 14 into 2, another layer. This is the second layer. So we know is saturated is 18, and we will deduct the pore water pressure, which is 9.81, and layer of the soil is 4. So we have 4, and then this is our third layer. The saturated is 19 divided by pore water pressure. We are subtracting pore water pressure 9.81, and Z is a very vital point, is 3.2. How we'll get 3.2? Because the calculation has the question has said at the middle of the clay. So we have seen the primary consolidation. What is the settlement of the clay layer? So causes when they say the clay layer, then we will find the midpoint of this layer. So midpoint is 3.5 divided by 2. This will be midpoint. So that's why we have divided by 2. This is the very important. So I will mark as a 3 star. And found sigma naught equal to 70.6 0.08 kilonewton per meter square, and CC we know 0.009, liquid limit minus 10. So we have given the liquid limit is here 40. That's why we have used this formula. Otherwise we will use 52. We will go to the 52 page. Then we'll go to the this is the very important. We can find the CC, this formula, CC 0.009 CC, and 5 into CSU and others, and found this 0.27, and delta sigma is 100 is given, and CC equal to C E naught, void ratio is given 0.8. Here is the given, and lastly we can find out the settlement. So as we know, this is the normal consolidation, then we will use CC into H. How we'll get? So if we go the formula sheet, then we can see here the sigma naught is greater than pre-consolidation. Here sigma naught is 76, but there is no pre-consolidation is given. Pre-consolidation is 200. So we have found 76. 76 is less than 200. 76 is less than 200. So we have used this formula, CC into H divided by 1 plus E naught into sigma plus sigma, delta sigma plus sigma naught, and use this and found the settlement 0.91 meter. And answer B will be, we know we have found sigma naught here, use this formula 76.8, and delta sigma is 100 is given there. How we will get the delta sigma? Okay, delta sigma is given here. And found 76.6. So we have seen here the sigma is 76, which is less than sigma naught, which is given 200. 200 here is a 200 is given, and sigma plus delta sigma, which is also 176, which is also less than 200. So we can say this is over consolidation, OC. So OC, when you will OC, then you will use CS. Okay, we know the CS. If we have already calculated here CS 0.270.009 equal to minus 10, and 5 into CS, and found in this way we have found CS equal to 0.7. So we will use settlement S equal to CS. This is the main our factor. But how we'll get? We will found this condition. If this condition is satisfied, then CS will be here. CS equal to H divided by 1 plus E naught log sigma naught plus delta sigma into sigma. So we have calculated sigma naught is here 76. How we'll get in this way? We have get 76, and we have known the 76 is less than 200. I will get sigma C. This is sigma C, is given in question 200, and then we have know the delta sigma. How will get the delta sigma? Delta sigma is given in the figure is 100. So if we add the 100 into 70.6, then we will go at the 176.6, which is also less than 200. So 200 is less than this condition. So both conditions are satisfied for getting using this settlement formula. So we will have used the CS equal into H 1 plus E naught plus log sigma naught plus sigma naught plus sigma delta sigma, and found in this way we have found the settlements also 0.038 meter. And if we want to understand in the graph from this portion, then we have seen here in the question has given the pre-consolidation is 200. So in this graph we have fixed the 200. Now we'll see the what is the value of sigma naught. Sigma naught is 76.08. I will get in this way we have get the 76. So 76 is less than 200. So we can say in this way the left portion the upper consolidation will be here, but because of the left, the point is the left portion. On the other hand, we have added the sigma naught plus delta sigma, and it is also the less than 176.08, which is also the point will be denoted by in this way, and found it is also less than the 200. So we can say this is the over consolidation soil, and we will use when the soil will go over consolidation, then we will use the CS. Okay, and in this way we have found another results. And number 3 we can see here sigma plus sigma naught, which is we have found 76 plus 100, which is also 76.08 kilonewton per meter, and pre-consolidation is already given is here 150, but we have been seen here the sigma naught is 76, which is less than 150. This is here, and on the other hand, when we will adding with delta sigma and found this is the 176, which is the greater than 150. So we'll use the this is the satisfied of the two conditions. So if we go in the formula sheet, then we'll go if the two condition is satisfied, then we'll use this formula. So let's use this formula. This is for sigma C, CC portion, and this is also CS portion. So we have used this formula and applying and found 0.06 meter. These are our answer. And let's see another example is here. A soil profile is shown in figure in laboratory consolidation test, where the specimen is called the middle clay layer. Here is a middle clay layer. The field test consolidation curve been interpolated from the laboratory test shown in the figure. Calculate the settlement of the field causes primary consolidation for a surcharge is given 60 kN per meter and applied on the ground surface. Here is the we can see the applied load. We can see here the delta sigma, and 60 kilonewton per meter, and clearly are saturated 18 and E naught is 1.1 is given. How we'll get the 1.1? This is the E, so this is 1.1, and we can minus 1.01 and found 0.001. Okay, delta is found 0.001, and here is 100%, and here is a 32.7%. Okay, let's start. The effective stress at the mid level of the clay layer. So mid level of the clay layer, as the rock layer as a clay layer, so midpoint will be here, 8 divided by 2. So we are we know the basic formula is stress equal to gamma into H, and gamma will be saturated minus unit weight of water. We will use the unit weight of water, and Z will be the middle of the layer. The middle of the layer is Z. We have around here, and delta sigma is given 100 kilonewton per meter in questions. Now we'll adding this value, which is found 32 and 60, and we'll found the 92.76 kilonewton per meter, and E naught is 1.1 is given, and delta E will be from figure 1.10 minus 1.047. How we'll get this? Let's see. This is 1.10, and we'll 1.047. Here is a 1.047, and minus, and found the 0.055. Okay, so we'll use this formula for settlements. There is another formula we have shown here. We can see the, if we go to the formula sheet, then we will see this is another formula for finding the settlement, and we have known the all the value, which is delta E. H is known the 8 meter. So remember it, we have used the 8 meter just because of we are finding the settlement on the clay layer, and 1 plus E naught is given here 0.21 millimeter. So this is our settlement. Another example we can see here, and for the time required and 50% consolidation of a 20 millimeter thick clay layer, and drain at the both top and bottom in laboratory in 3 minutes of 15 seconds. And how in days we have to use calculate in days. Will be take a 2 millimeter thick clay layer of the same clay field under the same pressure in case reach the 50% consolidation, and in the field same sand layer are present at the top and bottom of the clay layer. Okay, let's see. So time factor, we know the 15 is given here. In lab 3 minutes of 15 seconds, so we'll take all the in seconds. Or in field we know the 2 meter, but drainage is condition 2 by 2. So drain, we know the in lab 1 inch. This is the fixed value of 1 inch. This is the memorizing point I have already saying here. This is how we'll get. In the true drainage we will divide by 2, but in for lab dr is 1. This is the constant value. 1 is 2.5 centimeter, which is 0.05 meter, and dr will be divided by 2. Now we will compare with lab with field, lab T and field T. So we know the TB value. How we'll get TB? See, this is the TB. The TB formula is given CB. This is the time factor TB formula. We'll compare this in formula sheet is given as lab into field. So we'll compare it the lab into field TB C 50 in lab, and dr square lab, and TB in field. So how in this way we'll get the field which for 124,000 second, which is for 14.44 days. So after 14.44 days, the time is required. Okay. So another we can see another example is given. Refer to the previous example. How days will take the field when 30% primary consolidation to occur. So primary consolidation with the 30%, E equal to 50%, and this is the 30%. So T1 divided by E1 square, T2 divided by N square. In this way we have found 5.2 days. And another example we have been seen, the 3 meter thick layer is double drainage. So double drainage, that means it will be d by h by 2 saturated clay under a saturated surface loading condition 90% pre-consolidation in 75 days. So there is a 75 days for consolidation. We have to find out the coefficient of consolidation of clay layer. This clay layer is a vital issue for the pressure range. Okay, so this is the given u equal to 90%, t naught is 1, we know 1.718 0.00 log 100 minus e log. So the how we'll get this formula? So we go, if we go to the formula sheet, this is this formula. So when u equal to u is 0 to 60%, then we will use this formula. When u equal to greater than 60%, 60, 70, 80, so this is greater than 60, then we will use 1.718.9009 log 100 minus c. So this formula we have used and found t and t is 0.484, and h equal to 3 meter, and h drainage will be 3 by 2 in the 100 square because we are taking the centimeter, that's why we will multiply 100, and t90 is 75 days and taking in second. So we know the t into cb into t90 into drainage square, and found in this way found the cb which is 00294 centimeter square. This question is very important for practical field. We are trying to solve this. The following question are obtain the one-dimensional consolidation test and void ratio after 100%. The consolidation under 150 kilonewton meter square was 0.94. That was under 350 kilonewton was 0.18. Under the both stress condition and normal consolidation under 350 kilonewton over vertical stress and experience 55% consolidation in 48 hours. So this is the under vertical press is delta sigma is given here, and the void ratio is we can found this comparison for delta E. We have found delta E in this way, and the coefficient of consolidation which is given the cb is given here. They calculate the primary consolidation settlement up to 1.5 meter. Here is the 1.5 meter of the clay layer under the center of the footing. This is the 1.5 meter. So compression index is calculation question, and initial void ratio is given, E naught is given, and saturated void is given here. In the field condition pre-consolidation is there, sigma p is given here 150, and delta sigma at depth 6.5 meter below is ground level 180 kilopascal. And second question is calculate the required the field condition complex 60% consolidation in 3 meter clay layer. So let's start. First of all, we will calculate the this delta naught, which is gamma into z, but we will use z first. Here is a 6 meter, 2 into 5 is a 6 layer, and 61.8 is given in the bulk modulus in the sand, plus z is here 1.5. Why we will use 1.5? Because the question is given thickness is 1.5, so the will be middle of the thickness, and gamma is given is 72.5. Here is 72.5 is effective. That's why we will not deduct the water pressure. So we have found 102. So 102 is given. On the other hand, we have seen the 102 is here, and pre-consolidation is 150 is given. 150 is given. So we can see here the pre-consolidation. The condition is sigma naught. We have found 102, which is less than sigma p, which is 150. On the other hand, if we go this condition is satisfied. Another one, if we calculate here sigma naught into delta sigma. So delta sigma is given here. Delta sigma is given here 350. So 350 plus sigma is greater than delta p. So we'll use this formula. 2% is this formula, so we'll use in this formula. Before we going to this, then we have to calculate cc. So calculate cc, we are knowing the formula of cc is here. We can use three formula for getting the cc. Yes, there is no information of liquid limit, then that's why we will not use this, but we will use this formula for getting the cc equal to delta e log sigma naught plus sigma e divided by sigma. So let's see. So in this way, delta e sigma naught is delta. I will get the delta e 0.984. This is the delta e 0.948 minus 0.812. This is the delta e, and sigma naught I will get in this way 102. And sigma naught divided by sigma is given 350 is given, and 150 is pre-consolidation is given here, and found 0.36. This is the cc, and if we got the cs, then we'll divide just 5, then we'll get the cs. As we know the relation between cs and cc, cc is 5 times greater than cs, and cs is 5 times less than cc. So putting this value here, and found the settlement is 0.09 meter. And last one, we have seen here, they calculate the time required. Now we'll show the time required is 60%. When the 60%, and then we'll use this formula. So this is our second this formula we have used two type of formula. When the d is 0 to 60%, then we'll use pi by 4 u by 100, and when the u equal to greater than 60%, then we will use this. So we have seen the 60%, then we will use this time factor, and putting the t equal to 0.224 10 to the power 6. So let's see another example here. The settlement is there. Determine the settlement of center of the raft mat foundation is here given here. The assume the normal constitution, dispute and figure, and data is given. So we can see here the sand layer, and sigma is given, and the mat foundation 8 meter by 20 meter, and d is given gamma w is given 10, and liquid limit is 50, and saturated and 71. So here is the groundwater is below the here. So let's start. We know the c is equal to 0.00 liquid limit minus 10, because there is a liquid limit is given here 50%, and minus 10 we have found cc, and sigma naught we have found gamma into h. Gamma is nothing but gamma into hd. So first of layer we have been seen here, the gamma is 15, so we have used 15 into 2. In this well there is no water, first 2 meter, and second one we have seen the layer is given in the water, that's why we will detect the water is 10. So this is our water level is 10 is detecting here, and a is by 2. Why we will detect the second layer is 6 by 2? Because the settlement is found, we always settlements is calculate in the middle of the layer, that's why we will deduct divided by 2. So and stress, we will know stress force per area. Force is given for 4 kilonewton, and area into 8 into 12, and found 5 kilonewton per meter. So for normal consideration, we are knowing the normal consideration as normal consideration is given here. So cc into 5 1 plus e plus log. How will get the normal consideration? So this is the very vital question. So normal question, if we want to go to the normal consideration, then the equation must be satisfied here. The sigma naught is greater than pre-consolidation, and sigma naught plus delta sigma must be greater than pre-consolidation. Then we will use the formula of normal consolidation. So let's go here, and we have seen here the normal consideration is all the information is satisfied here, and that's why we will use the normal consideration. So cc into h1 plus e of lot, and unfortunately we have been seen there is no pre-consolidation stress is given, but we think the question is missing this here. We have been as per our data, pre-consolidation must be less than, so your pre-consolidation should be 70 or 60. So 51 is less than 70, and 51 plus 5, which is 56. 56 is also less than 70. In this way we will use the normal consolidation, and putting this all the data is here. I found 46.18 millimeter as per code ACI 318 or ASC 707. The settlement must be less than of the red foundation. The settlement must be 75 millimeter or 3 inches. So we have found 46, so we can say this matte foundation is okay for the settlement. So another formula we can see here: calculate the consolidation settlement of the clay layer under the footing condition. Footing condition is given here. So we have been seeing sand layer is 5 meter and clay layer is also 5 meter. Okay, but water level is the below the 5 meter. Okay, let's start fast. We have calculating sigma naught as the first layer, which is 16 into, we know the basic formula gamma into H or gamma into Z. Gamma is given 60, and we will not deducting the water pressure because the water indicating after below the 5 meter. Okay, and the height is 5 meter, and second layer is 5 minus water, which is say 9.81, because the water level is below the 5 meter, and 5 divided by 2. Why we will use the 5 divided by 2? Because we will taking the settlement at the mid of this layer. That's why we will divide it by 2. Okay, now we are calculating the settlement, and CC into H divided by 1 plus E naught in log sigma naught into delta sigma divided by 10. So delta sigma is, we have been here, the delta sigma is given 10 kilo, and we have found the sigma naught is 100. So if we go to the this is this formula, then we have to must be fulfill this criteria: sigma is greater than sigma naught. So sigma p, how will get the information has missing. The sigma p must be 100, must be 150 kPa. Let's see, the sigma p is 150. So we have found sigma naught is 100, which is less than sorry, sigma p will be less than there. So okay, so this will be only 50. We can see only 50. 150, no, it's not 150. 150. This is 100 is greater than 50. On the other hand, we have, if we add 100 into 10, satisfy this formula, 100 into 10, which will be 110, and greater than also 50. That's why we will use the NC. And if we get this formula, we have used NC. This is also NC. NCP will be less. So this will be less. So I'm very sorry. So delta sigma p will be, let's see, the sigma p will be 20. So 20 is 51 is less than 20, and 5 plus 20 is 25. 51 plus 25, 56, which is also greater than this. That's why we will use NC. The condition is very clear, so the condition must be satisfied. And and second formula, the sigma p will be 50. Let's say because this p is 20, the question is missed. On the second formula, question is missed, sigma p is 50. So 100 is greater than 50, and if we plus 10, then this also 110, which is also less than 50. So that's why we will use CC. This is normal. This condition satisfied. That's we will CC into 1 plus H sigma naught into 1 plus, and found the and found the 0.6 inches, which is also less than less than 3 inches. The settlement is less than 3 inches or 75 millimeter. Then we can see this is the okay. Another formula we have seen here: calculate the settlement at 2.5 meter deep clay layer due to an increase 30. So layer is given, H is given here, and increase 30 kilonewton per pressure. So it will be delta sigma. Delta sigma is given at the mid height of the layer is given. Effective vertical stress at the height level is there 30. So 30 kilonewton per meter. So it is given. The sigma naught is already given. E is given 8 and CC equal to 2.2. So this is the given we have found. So we will calculate the settlement as CC equal to on the other hand, we have seen the sigma p is not given, but it's missing the question. So sigma p, let's see, sigma p is 20. So 30 is greater than 20. 30 plus 30, 60 plus also greater than 20. So that's why we will use the settlement this formula CC into H 1 plus E naught plus log sigma naught plus delta sigma divided by sigma naught. In this way we have found 0.992 inch, which is also code is required as per as C7 or ACA 390. The settlement must be 75 millimeter or 3 inches. So we can say the settlement is okay. So another formula we have seen here. They calculate the settlement 2.5 meter clay layer due to increase 40. So here is the given. At first we have given the H, and the increase pressure, which is delta sigma, is given, and pressure mid height of the given, and effective vertical stress at height is 30. H is delta, which is given. Sigma naught is given, and given E equal to 0.8 and CC equal to given, and another data is missing, which is pre-consolidation. Is, let's say it is 20 kilonewton per meter. So you can see 30 is greater than 20, and 30 plus 40, which is 70, is greater than 20. So this formula, this criteria is fulfilled. Then that's why we will use normal consideration CC equal to H 1 plus sigma naught plus sigma, and found on the settlement over 0.10 meter, which is 4.02 inches, which is greater than 30 inches. So this is the settlement is not okay, we can say. So we have to reduce the pressure. Pressure means the delta sigma, which is pressure of the building. So we can reduce the size of building, and we have to deduct some story. And another formula we have been found, we have been seen here. We have been seen another the thickness of the clay layer is 2.5, which is given 2.5 H, and the void ratio is 0.7 is given, and consolidation is also 0.28 is given, and the existing pressure at the mid height of the layer is 40, which is sigma naught is given here, and the 30 kN pressure is applied at the mid, which is delta sigma is given, and find the consolidation settlement of the layer. But another question is missing. The pre-consolidation is given here. Let's see 20. So 20 sigma naught 40 is greater than 20. So this satisfy first criteria. Another is sigma plus sigma naught 40 plus 70, 30 is 70. 70 is also greater than 20. So this two condition is satisfy this criteria, then we will use normal consolidation formula. Otherwise, if the criteria is fulfill this criteria, then we will use the over-consolidation, which is we have to use CS. On the other hand, this is the another criteria, third criteria. Let's say here C is equal to and use all the use the value, and found 3.10 meter or 3.93 inches. We can see another example, which is clay layer strata 5 meter thick, and the initial void ratio is given 1.5, and effective overburden pressure 120, and what is the increased pressure void ratio 1.44, and volume of the coefficient is compressive, and also calculate the final settlement. Okay, So we are using here 1. CAB 1.5 which given, and 1.44 is also given, and we'll take the average point 1.47 MB is given, and 5 is the height, is also the given. MB, we know the MB formula is here. So if we go to the this slide, the formula sheet is MB. The MB formula is given here, QB equal to 1 plus E naught. So we have used this formula and found delta sigma 122 kilonewton per meter. Then we have used the final settlement as equal to MB delta sigma into H, and found 4.72 inches the settlement. So another formula, another calculation we have seen, the 2 meter deep clay layer and coefficient of the compressibility is 2 meter is given, and 200 you can say. Compressibility CMB equal to 2.2 is given. The pressure from 1 to is given the 2 kilonewton per meter, and sigma naught is given. Effective power station 1 to 2. So we have been taken the 2 kilonewton per meter. And what is the settlement of the clay? So we know the MB delta settlement equal to MB into delta sigma into H, found 3.8 centimeter, which is 3.1 inches. So another example we have been seen, the calculate the settlement with the soil depth is given 2 meter, which is 200 centimeter, and coefficient of the compressibility is given 0.2, and under the pressure condition of 2 meter, which is given delta sigma here. So we have used the settlement formula MB equal to delta sigma into H, and found 18 centimeter. Okay, let's see another example. Here the fine Peter is thick, and initial void ratio is given 1.5, and effective overburden pressure is also 120. 120 is given here. What is the sample subject to input pressure 120, which is there in delta sigma, which is void ratio of is given 1.44, and determine the coefficient of the compressibility and final settlement of the stratum. So del E, we know E naught equal to E, so we have found del E 0.6. So CB, the formula we have taken the average, and 1.46. MB we have used here MB formula, taking the formula sheet, and found this value. And settlement, we know the settlement as equal to here. So if we go to the settlement here, the first formula settlement MB equal to M as equal to MB delta sigma into H, and putting this value, and found 0.12 meter. Okay, so let's say another example, which is clay layer is given 2 meter, subject to the loading 5 kilonewton per meter. After 1 year loading, the overburden consolidation is 5%, and the layer double drainage. So double drainage, that means H by 2, and the double drainage, and delta sigma is given, and U is 5% there, K is given, and T equal to 0.00. So TB, we know TB equal to pi by 4 U by 100 square. Why? Because the drainage is less than so we can say the layer is take 90% concentration. Sorry, the overburden 50%. The loading is average 50%. So 0 to we know 0 to 60%. 0 to 60%. Then we will use the time factor formula is here. So we have seen the percent is 50%, which is 0 to 60%. That's why time factor 0.198, and TB equal to TB in this formula we have used the formula of TB as the first formula. TB equal to CB TB and dr square, and putting this value, and found CB is here. Then finally we will use the Ki equal to MB. How we'll get this? We have now we'll go to the formula sheet. Here is a K. K equal to CB TB MB, and putting this and found M, and lastly we will calculate the settlement. So settlement is formula is here. We have shown here the settlement, and found the settlement 0.001 centimeter. Settlement after 1 year will be 0.5. So these are the final and the time required to reach the 50% consolidation. 50% means 0 to 60. That's why we will use this formula. We are known this formula, that 0 to 60. and the soil is specimen 3% 3 centimeter thick, and the tested, so this value is tested over uh, over single drainage condition was 30 minutes, and determine the time required for the same soil thick to reach the same degree of saturation is the double degree. So the first sample soil is TB, we can use the formula of TB and found CB is here, and the for second sample we have used this same formula and found TB equal to 2 hour or 333 minute. So we have seen another example is a clay layer is 4% thick, is subjected to pressure 55 kilonewton per meter, and layer has double drain, that means it will be divided by 2. So and undergoes the 50% consolidation. If the 50%, then we will use the TB use pi by 4 into u divided by 100, because is the given 50 is between 1 to 60% in 1 year. Okay, determine the coefficient of the consolidation, take 0.196, and if the coefficient of permeability is given 0.0 meter, and determine the settlement. So lastly we have to determine the settle for only 1 year, and rate of the flow in water unit and 1 year. Okay, let's see. So use this formula, TB is found, and putting assembly TB is here and found CB is here. So for the coefficient of K, we have used this formula and found M, and lastly settlement, use settlement 0.57. So settlement after 1 year will be 5%, 50%. We have given in question undergoes the 50%. That's why use this and found the settlement 0.216, which is the 50%. 50% will be. So T, we can use another formula for T equal to here and found value of the phi, and again if we put this value of T, then found is T also. DT is also found here. So ds divided by dt found 0.13 meter per year. This is the rate, and the distance per unit area surface will be 0.18, which is the ds by dt divided by 2, because this is the double drainage. That's why we will use divided by 2 and found 0.00. So another example we have been seen a 3 meter thick of the double drainage. That means it will be h divided by 2, and of the saturated clay under surface building under 90% concentration. So 90%, that's why our TB will be the formula will be changed, because the 90% is greater than the 60%. So TB will be 1.78 minus 0.99 log 100 minus e. So this formula I have used and found 0.848, and finally T90 90%, and TB equal to CB and drainage equal to 3 by 2, because this is the double drainage. That's why we will divide it by 2 and found the CB value of CB. And we have seen here the another. This is our maybe last example we have been seeing. So let's start. The time required for 50% consolidation, 50% consolidation, 25 millimeter thick clay layer in drainage at the both top and bottom. So this will be divided by 25 divided, because the both are drainage. In the laboratory, so laboratory tested 2 minute 20 second, and how long days will be take for the 3 meter thick clay layer for the same clay layer in the field. So we have to found the field layer under the same pressure increase to reach 50% consolidation. In the field, there is a rock layer at the top and bottom. Okay, so we'll compare this top lab to field. So we know we use the TB formula, TB equal to CB, TB into drainage square, and putting this value and found that TB equal to this seconds, and which is 93.33 days. So given lab into field, so all the formula is given, all the information is given. In lab, A is equal to 25. On the other hand, we can see the field is the layer is 3 meter. And drainage in lab, we have seen the double which is the double drainage at both and top and bottom. That's why we will divide it by 2 and found TB equal to 140 140 second, and same way we will use the field. Okay. So these are the our last example. I wanna say this is our last example, so we can say this example very clearly. In the laboratory consolidation at 1 inch thick sample is clear layer is to 90% consolidation, and is 2 hour. How long will take to 20 feet thick clay layer drainage from top surfaces only. Clay layer is undrained by impermeable rock and reach 90% consolidation. Okay, so given data is for sample 1 is thickness is 1 and drain is 90% and T equal to 2 over. Okay, for sample 2 we can see that T we have to calculate, and A is equal to 20 feet and D and it is also 90%. So as the 90%, that's why we will use the time factor formula is this formula. Otherwise, if we see the 60%, then we will use the time factor and the above formula. Okay, and found the time percent point of 848 and time factor another. We have used the time factor this formula, and drainage is 1 because this is the sample we have used, and found CB equal to 0.42. Again we have used for the same and found drain equal to 20 because the 20 is feet and we will take in the inches. That's why we will multiply by 12, and found the time is 115200 hour, which is 4800 days. So this our lecture. So if you have any question, let me know, but I cannot give the appropriate lecture to you as many of the obstruct and noise is coming. But if you try yourself, then you can do best yourself. Okay, so before I'm leaving, I just sum up the lecture. This lecture is on the compressibility of soil. This is the settlement, and we'll use the settlement. These are the total settlement we found that by 3 type of, which is primary consolidation, secondary, and elastic settlement. So and then we have gone here. We have seen the when T equal to 0, then stress is increased and pore water pressure is also same, but the effective stressor is 0. And the T equal to T is greater than 0 but less than infinity, then stress is here, and the pore water pressure is decreased also because the water is spreading in this way, and the effective stress is also this curve. And when the T is infinity, then the stress is here, and the pore water pressure is 0, and then sigma equal to sigma not equal to sigma s. So here is the time scale, the initial compression and primary consolidation and secondary compression. There is a 3 stage we can see here, and then we can see the P log E curve or Boyd ratio versus pressure curve. We can see here this axis is Boyd ratio E and E2 E1 and delta 2 delta 1 here, and in this way we have found the compressibility index CC. And then we are trying to understand the basic formula: normal consolidation, over-consolidation, and pre-consolidation. And then over-consolidation how will occur in the soil, and trying to sketch up the pre-consolidation. And then we are summarize the formula: must be memorize this formula, otherwise you will not what I will say, you will not solve this problem properly. Okay, so these are the formula, and this we have been seen the for quick settlement of the formula. We have another. Here is the formula sheet. We have shown to you this formula sheet and this formula sheet, both are the same. I've been taking note during our time. Here is the drainage basic. When the sand when the sand is between clay and sandy soil, then the drainage is true drain. Then we can say the water will be seepage in both way. That's why we will take two drainage into h and divided by h by 2. And this concept we are applying during our solving the questions. And this is our first example, and in second and third. And there is a this is the our you can I've been seeing the you can take you can take what I will say screenshot for your solving selfly solving, and then take another screenshot, and this is the take the another screenshot. This is the another example of TB time factor solving, and the time factor it is taken from BM dash both. Okay, goodbye.